All right, so we had a late cancellation. Bogdan, was going to present the tracing stuff he's working on, couldn't come. So I'll take the chance to talk about one of the things I brought up at LSF conference that we attended a couple of weeks ago. What I wanted to talk about there was how we could potentially do a lot more benchmarking as a community. So we do a lot of we do have a lot of shared testing in block tests and in FS tests, and that works really, really well. Like, we couldn't live without those tests. And I think we could do something similar for benchmarking. And why would we do this? Well, it is because benchmarking is goddamn hard. The more I do it, the more I realize I suck at it. And I think it's due to that it's like easy to do a benchmark. You can define it, you can run it, and you will get a result. If that is like useful or right, it's hard to know. And this is due to a lot of different challenges. One is just selecting the right benchmark that not only you care about, but actually reflects some sort of desired behavior, like you do a metric that someone else really cares about. And once you know what you want to measure, you have to design a workload that sort of emulates that real-world workload. And you'll do that in file system via FIO, for example. And FIO is a great tool. It's just that it's easy, even if it's like awesome, we can shoot ourselves in the foot quite easily. You could just measure the wrong thing. So it would be good to have more eyes, get reviews from people looking at the scripts to make sure we don't have any subtle errors that just makes us not measure the right things. And once you have a result, you have to analyze the result to make sure that this is actually measuring some sort of positive impact or just understanding how noisy your results are. So you will actually be able to separate the sort of real signal from the noise. That's all tests or benchmarks will have. And it's also very expensive to do benchmarks. So that's another reason for sharing this effort. It takes time from us to set up, run, and analyze it if you want to do it properly. And it's also costly in terms of hardware, because if you want to detect regressions in the kernel performance, for example, you have to use the same system in the same circumstances, like same temperature maybe, like in right phase of the moon, to be able to measure, especially if the differences are small. But like 1-2% of a performance difference really, really, really matters. But you really need to have awesome benchmarking to be able to measure that consistently. So my question to the LSF community and also to you is like, can we share more of this effort? Can we share workloads we care about, we have defined? Can we share the frameworks that can execute them and analyze the results to make sure that they're statistically significant? And also share results in some form, because it would be useful just to share, this is what I measured. Doesn't mean like you'll get the same result, but it could be very useful to someone else to see what you've done. So those are sort of my questions to the community, because many would benefit. It's useful for file system developers doing optimizations. It's great to get them being able to like upstream a workload definition so the community can see what you've actually done. Like, I fixed this bug, here's the XFS test. We could do the same with a benchmark. It's also great to have suits that we can check that our results don't regress anyone else's workload. Academics doing research would also love this sort of thing, because most of the time they make up their own micro benchmarks, and then they run some like standard workloads that all the other academics are running. Might not be very relevant to today's like hyperscalers or today's modern workloads, but they do it because it's there. Like everyone else did it. If you would have a project that would have a collected set of collected workloads that we as a community would care about, they could just pick it up and run it and publish the results in their papers. Also, vendors designing hardware would love easy to run benchmarks to be able to optimize for something that is just not completely random and not completely sequential when it comes to I/O. But the things that are in between that are interesting to maybe optimize for. And also, like the enterprise Linux engineers, like Red Hat, SUSE, they love this because they really want to make sure that their customer experience does not degrade for new kernel versions and so on. But of course, I'm not the only one who sort of saw this problem. So there are some projects out there already. We don't have to start from scratch. And we have two big ones for file systems. And one is MMTest, that's maintained by Mel Gorman. And this is something that's heavily used in SUSE, has quite a lot of contributors. And that is more of a generic framework that can run not only file system tests, but also memory management tests, hence the name. And so it's a big harness with sort of plugins for different tests called shell packs. And they do, so it's very config driven, so you can configure it to do almost anything. And it also has sort of post-processing doing statistical analysis. So it's sort of a generic test or benchmarking suite. And then we have something more directed for file systems called FSPerf. That's heavily used by the Btrfs guys. They use that to track regressions in their releases. And that is something simple, developer-friendly, not as like all-encompassing as MMTest. Both these test suites have the possibility of adding more monitoring inside for ftrace, or in the Btrfs case, doing detailed fragmentation analysis. So not only look at the actual just the benchmark output, the numbers for like throughput and so on, but also secondary things like CPU usage and IO stats and so on. And I think this is not an either-or thing. I think these test suites or benchmarking suites are sort of complementary, and I think they're both good. And that is something that also I think was the consensus at the LSF discussion. What strikes me is there are fairly few contributors to this. So I wonder why don't people use this more? So my question to you guys is how many of you do this type of performance regression benchmarks or benchmarks for papers and so on? Yeah, so it's quite a few. So have you tried MMTest and FSPerf? Yeah, okay. So what is your experience with that? That's what I would like. Is this a good user experience? Did you consider contributing to it? Yes, sir.
It's not very interesting. I was just working together with Mel Gorman, and I had to change some stuff in memory subsystem, and I tested it with his test, and I didn't contribute.
Okay,
anything,
but it was
it-
like you could pick it up and just run it, and it was.
It wasn't. No,
No.
it was a little bit difficult to use, but I had Mills' help, so that was.
Yeah. So it's something like that's built for. Is it something that's built for SUSE engineers, and that like you have to be a wizard of test to use? Daniel, you have also been.
No, so we have a few guys working full time with that framework, and they know all in and out how to use it. For a random user, there's a learning curve. If you use it wrong, you can destroy your file system. Guess what I did? So yeah, it's good. If you get the hang of it, it's pretty good, awesome. But as I said, there are a few things which are dangerous if you use it wrongly or think like, I don't need this, and then suddenly your file system is gone.
Okay, could it be like you had some sort of safety mechanism or better documentation, better like?
As you said, it starts off that you have to write the configuration, what you want to test. There are a few examples there, and you pick that one and you say, okay, you have to define like the block device, whatever, and then you let it run. And one thing in the beginning was kind of strange, obviously, is you have very complex setups where it downloads first MySQL server, compiles that, installs that, then let it run, and it does a lot of things, right? And if your configuration file is just wrong, you end up in a disaster. And that was my experience. But when you get the hang out of it, it works. I mean, in the end, you get these nice graphs where you see like A/B comparison, and you see how much, if it's relevant or not, is significant change or not. That thing is, I like that kind of thing. I have never tried FSPerf, but just from using tests, I like the results thing, to look at the statistics.
Yeah, I think that you need something like tests to really catch regressions. Well, FSPerf is more like, this is an easy like A/B test, and it's much less overhead to get started with it. It's more similar to block test or FS tests. It's like more intuitive for me to get into.
Yeah, and what test also very good is like a series of kernels. So you can have like 10 different kernels and see the performance of each one compared to the other one, which is actually very interesting. So if you do like 10 runs, you get 10 different results with the error bar and everything. You don't have to do that manual, basically. The framework gives you that for free. I don't know what FSPerf does that.
There is a database you can store, but I have mainly used it for A/B testing.
Yeah.
And that's the difference between this as well. Like you just get text output from tests. Like there's no database or anything. Yeah. It's sort of convenient to store things in a database like FSPerf does, but then you have to sort of manage a database, and that's annoying.
Yeah.
Like if you add another like field, I have to upgrade the database, and I ended up having to do a lot of.
Yeah, that's what you get for test free, and it stores it in a database. It creates the web page where you see all the data, historical stuff. That's actually very handy that you don't have to do it yourself.
Yeah. Yeah. I wonder, like Andreas, you've done a lot of benchmarking, right? Did you consider like sharing your scripts somewhere, like because?
Yeah, I shared a lot of it actually. I wouldn't recommend anyone to pick it up and use it because you know how it goes. You build something and it becomes ever more convoluted and probably not easy for people to pick up.
Yeah, it's like everyone does their own CI framework, right? But yeah, if we have something common, it's easier for people.
What we do is we build this system where we can boot hardware nodes and they can run. We have a driver based around FIO. They define a set of settings you want, and you get like cross product. You get test across all of your problem space. You get collect the data, calculate the use some statistics, use a t-distribution, get your error bars, all of that stuff. And you get the plots, basically, right? It's in my GitHub. You can go check it out.
Yeah. But did you consider like finding like perf or FSperf or it's block tests probably? But
so we are running XFS tests as well for performance, for functional regression.
Yeah.
But that's a different story, right?
Yeah.
We're not running FS tests. FSperf, because the Fire ones are enough, right, for what we do.
Yeah.
But it is difficult, and I think more than the tools, we should establish guidelines for how we measure and how we make sure that the measurements are reproducible. Yes. And so, like, what else is running on your system? How do you control your system? The device that you're measuring, if it's a flash-based device, it deteriorates over time. So how it matters if you benchmark for a year, I can tell you. Yes. Every day. The numbers you get on day one are not the same you get on day
it's a black art to do this, but like there are a lot of things we can do in common, right? Everyone will have their own systems and you will get different results. Like there's no there's no one, it's not a single truth when it comes to.
But tracking performance over time can be difficult in situations like that.
Yeah.
So I think more than more tools, we need guidelines, like community accepted guidelines. This is how you measure stuff, right? Because we all invent the same.
I guess the SUSE guys must have like a good idea of how to do this, or. No.
So I.
One thing about measurement is sort of what we have to be focused on, because that's the most important thing. And one thing is costs. Cost in energy, CPU cycles, memory, whatever. And I don't see benchmark system that is collecting that type of information.
Yeah, can do that.
Energy is of course very hard to measure, but sort of CPU cycles and instructions that is being used.
Utilization. You can measure these things.
Energy is quite hard.
Oh yeah, energy is hard. But I guess you can hook that up if you want. If you have the equipment, you could make something that measures it, right? But
but sort of the point is sort of the costs should be part of
it's not only like the raw performance, right? It's.
So I haven't done a lot of block testing, but I did write a test tool for networking, as I showed this morning. And this came out of, I think there's a lot of sort of carryover here, right? And networks are also hard to test, and people have been doing it wrong for decades. So my sort of tool came out of the late Dave Tart spent a decade trying to yell at people to get them to test the right thing, with some success. So it's now in the speed tests and so on. So what our focus was with that tool is to have canned tests that are sort of named and easy to run. So that was the tool. So, and it's sort of what it does is it runs a test, puts everything into a gzip JSON file. So you have a one file that's the data for your test run, and then you have a tool that can load them, and you can graph them, and you can compare them, and so on. So that was sort of the interactive stuff. Yeah. And I think that had some success. People are still doing it wrong. So I don't think you can, you cannot avoid that. But I totally agree that having guidelines, and so even with this tool that is easy to run a test, you still need to know the system you're doing. You need to know all the pitfalls. You need to know how do you configure very, very detailed things, which I don't think there's a substitute for just learning that and working with it and sort of.
No, but we could do we could have presentations on it. Continue talking about it, right? That's one solution to it.
Yeah,
right?
and like in the networking space, there's a whole academic conference that's called the Internet Measurement Conference. It doesn't do anything other than measuring the internet, and it runs annually, and it's pretty high profile. So like there's also, But consider this like you're on the right track here. Right? Consider this something to work on in itself that's worth doing and developing and sharing.
Yeah.
Is definitely a right step, I would say.
Thanks.
The one problem with these ones, especially MM tests, is that it's actually doing two things. The one is actually performance test, and the other one is also regression testing. So if you look at it, you find that there's tons and tons and tons of tests which test for specific corner cases. I mean, XFS test is actually part of the M test suite, and if you just look at that, that's, I mean, how many tests are there now? 4,000 or something in the XFS test. So it's just piles up, and it really makes it hard to figure out which of these thousands tests do I need to run, which should I run. And also coming back to your question about cost of that. I mean, performance is precisely there to drive the machine to its utmost edge. And guess what? That cost. So I'm not quite sure how you would address cost, because that's precisely what you're trying to measure here.
I think that's how it depends on how you define performance also. Like, if you want low power or like a balance, right?
But that would be that would actually be an interesting thing to have, because performance is primarily indeed pure performance. I mean, all of these things came are rather old, where memory power management wasn't really a thing, and also most of these performances are actually driven by large machines where you simply don't care. So yes, having the power measurement to go with, or rather having a combined test for power measurement and performance, would be possibly a good thing.
Yeah. I mean, if you do improvement and optimization, you might start eating more CPU, we get more throughput, and it's like, that's not a trade-off that everyone wants to make. So it would be good to be able to publish these numbers together, right? I mean, people do, but it would be just good to have an automated way to do this, and to reproduce stuff is a big thing, right? Yeah, so something that was discussed a little bit in LSF was to just make like pre-built VM images to like a packaged suite of stuff. You just press play and it will do some benchmarks. But that doesn't sort of solve the problem that you still have to understand your system. You still have to understand the results, right? So I think I really like your comment, Tuke, about like just we should talk about this and continue and share what we do. And I think we could put up our benchmarks in these projects, but it's like it's not as easy as that. Yeah.
So for that, we also have to mention the KDevOps, which is sort of tangent to this, right? Which is a framework there's like a lot of scripts to bring systems into the right state for running your tests. So it has a lot of Ansible stuff, and you can test on all kinds of different distros, and it has support for XFS tests. And
yeah, I mean, everyone runs XFS tests in some sort of harness.
Right, but it's just it's an honorable mention in the space of
click a
button.
Something we could learn from,
And it has connectors for cloud providers and all of these orchestration frameworks, so you can hook up your cluster and run your tests.
Yeah. All right, cool. I think it's approaching that time where we start moving downtown.